Hi everyone, Dr. Webster here, and this video is on conducting a one-way between subjects ANOVA. I'll be replicating the lecture example from class where we are looking at differences in feminist prejudice between liberals, moderates, and conservatives, and we're conducting a one-way between subjects ANOVA because we have one independent variable here, political orientation, and we have three independent groups. So we can't conduct an independent samples t-test because independent samples t-tests, we only have two groups. Here we have a third group. And so we are conducting a one-way between subjects ANOVA, looking at whether feminist prejudice differs between these three different independent groups. So we'll go to Analyze, General Linear Model, Univariate. And you'll get this window pop up, and you can stretch this out, make this bigger. And so we have our dependent variable, which is feminist prejudice. So we're going to pop that over. And then under fixed factor, that's where we are going to put our independent variable, political orientation. So this is liberals, moderates versus conservatives. And so DV, IV, and then under post hoc, you'll get another table that pops up here. And so we need post hoc tests for political orientation. So if the ANOVA table, if the omnibus table, the p-value in the omnibus table for political orientation is significant, then our post hoc tests, the multiple comparisons, also SPSS calls them, will tell us which groups actually significantly differ. And we are going to select Bonferroni. Again, sounds like a pasta. Bonferroni with meatballs, because it best corrects for type 1 error, because we're making multiple different comparisons. And so we want to be careful about, more careful about saying something is significant when it actually is not. That's a type 1 error, right? Saying there's a difference when there actually isn't in the population. So that looks all good. Continue, and then we're going to click Save. And when you click Save, this other window will pop up. And here we're going to select Cook's distances, Cook's D. So this will help spot outliers here. And then we can hit Continue. And then under Options, you can tell this is already a lot lengthier process compared to conducting the independent sample t-test. Under Options, we're going to click Descriptive Statistics, Homogeneity, and Estimates of Effect Size for our purposes. And then we'll hit Continue, and then we will finally paste. So here we have our syntax window. Here we have the syntax to the command to run our one-way between subjects ANOVA here. Again, a little bit longer syntax than the independent sample t-test. So we are going to highlight and then run this. And then we'll get an output window popping up with all our stuff. A lot more tables, right, than the independent sample t-test. So a few of these we don't really need. So like the between subjects factors, we really don't need. So because we get duplicate information in the descriptive statistics box. So I'm just going to delete that because we don't need it. And then we have our descriptive statistics, quality of variance with Levine's test, our ANOVA table, and then our post hoc table. Before we get into any of this, we want to check our Cook's D values though. So we're going to go back to the data set and then check out our Cook's D variable. So when you run the ANOVA, a new variable appears here, Q_1, this is Cook's D. And so we're going to right click, and then sort descending. So sort descending from largest to smallest. And here, if you remember from class, Cook's D helps spot potential outliers. So every participant gets a Cook's D value, and this Cook's D value reflects how much the results will change if that participant is taken out of the analysis. We don't want any one participant to substantially affect the results, right? Because that is an outlier, right? An outlier substantially affects the results, right? An outlier can affect the mean, the standard deviation, the inferential statistics, because it affects the standard deviation. So, there's a domino effect here. So what we're looking for once we sort this descending is very large jumps in between the first few values, especially the first and second value, which we don't see any big jumps. We see a nice gradual decrease in Cook's d values from 0.05, 0.04, 0.03, 0.02. This is exactly what we want to see. If this first value was more like, 0.25 and then it went to 0.05, that would be a lot more concerning. Again, there's some guidelines out there about how big the first value has to be in comparison to the second value. But I just find, like, if you suspect that there's an outlier, then filter them out, take them out of the analysis. You can save this as a new data set. You can, delete that row if you want to. There is also another way to filter participants without actually deleting them from the data set. A little bit more advanced stuff, though. And take them out, rerun the analysis, see how much changes. If your p-value is less than 0.05 and it's still less than 0.05, and you check your partial eta squared value, if that doesn't change much. So you just want to see how much things change once you take that participant out. And if things don't change all that much, if you're going to come to the same conclusion, leaving that person in, then just leave that person in. Okay, so let's go back to our output. And then we can check out Levine's test. Levine's test should be non-significant. And so you'll probably come to the same conclusion regardless of what p-value you look at here, but just based upon the mean, we have a non-significant p-value. It's 0.917. So that's exactly what we want to see, is a non-significant Levine's test. So check. And then we can take a look at the actual mean scores here. And if we wanted to, as I did in the lecture slides, switch that to 2 decimal places, just a little bit easier to look at. And just looking at the mean scores here, it looks like, conservatives are reporting more feminist prejudice compared to liberals and moderates, which was counter to what maybe we predicted in class. We thought moderates, they're in the middle, so they would score in between liberals and moderates, but it seems like liberals and moderates are scoring very similarly here, while conservatives are scoring perhaps a lot higher. But again, we'll have to check to see if there are significant differences between these groups, and significance does not equal importance, so we'll also have to calculate Cook's d. So we go to our between subjects effects table, also called the ANOVA table, also called the omnibus table, to see what we have going on here in terms of whether we have our p-value here for the omnibus tests for the ANOVA is actually significant. And if the p-value is significant, then that means there's a significant difference, at least one significant difference between the groups here. And there should be. When we conducted the independent sample t-test, liberals and conservatives significantly differed. Conservatives reported a lot more prejudice compared to liberals. We should replicate that here. What we're more interested in with this ANOVA is really where moderates are falling in comparison to liberals and conservatives. So if we take a look at the test of between subjects effects table, the ANOVA table, the omnibus table, and we take a look at the p-value in the row that has our independent variable here. So we see political orientation here. That is our independent variable, our IV. And we check out the p-value, and it's less than 0.001, which means significant, right? So this means that there's at least one significant difference between the three groups on prejudice towards feminists. And then we also have our degrees of freedom within the two, right? That's in the IV row. We have degrees of freedom between, or error. So that's 119. So we'll have to report the two degrees of freedom here, 2 and 119. And then we have our F value. And so technically SPSS uses the 2 and 119 and the F value to find the P value here, the less than 0.001. So we'll report 2, 119, we'll report the F value, we'll report the P value, and then we'll also report partial eta squared. As we discussed in class, partial eta squared is the effect size for political orientation. So how well or how much is political orientation explaining in terms of prejudice towards feminists? So we can't calculate a D value because a D value reflects a difference between two groups. Here we have actually 3 different comparisons. We have liberals versus conservatives, liberals versus moderates, moderates versus conservatives. So partial eta squared reflects how big the differences are in between all the different groups, and tells us, well, how much is political orientation explaining in terms of the differences in prejudice towards feminists, right? Because we have a lot of variability, a lot of differences in terms of prejudice towards feminists. So how much of that is explained by political orientation? How much is political orientation, by knowing your political orientation, how much insight does that give us in terms of your prejudice towards feminists? And so partial eta squared, the range is from 0 to 1. And then we can multiply this number times 100 to get a percent. So we can multiply 0.134 by 100, and that will give us 13.4%. So political orientation is explaining 13.4% of the variability in prejudice towards feminists. And if you remember from our lecture slides, 0.134, right? That is just on the cusp of being large, right? It's almost large, technically still medium, almost large. I'd probably say, this is a medium percentage, but almost large percentage if I was, because it's really, really close, right? So regardless, right, medium and large effects generally are important. So it seems like political orientation, by knowing someone's political orientation, that gives us some pretty good insight into how much prejudice toward feminists you are reporting. All right. So we have a significant p-value in the ANOVA table, the between subjects effects table. So now we move on to our post hoc table. Our post hoc table will tell us which groups significantly differ. And the post hoc table, as we talked about in class, has redundant information, right? So if we look at the first comparison here from liberals to moderates, right, we can go from liberal to moderate, or we can go from moderate to liberal. We're going to get the same information regardless if we go from 1 to 2 or 2 to 1. So if we go from 2 to 1, so if we go from 1 to 2 here, right, we look at the mean difference between liberals and moderates, which is 0.04 if we round to 2 decimal places. And it's a little bit easier if we round to 2. And then, so that's the mean difference. And then we have our p-value, or sig value. And here we have a sig value equal to 1, which is the highest p-value that we can get. So we are actually 0% confident that there is a true and real difference between liberals and moderates. So this 0.04 is not far enough away from 0 to indicate a true and real difference. We are not at all confident that there's a difference between liberals and moderates in this study. All right. And then we have liberal to conservative, so 1 to 3. We see looks like a pretty big difference here, 1.52, and then our sig value is 0.001, and so this p-value is less than or equal to 0.05, so we do have a significant difference between liberals and conservatives. And then our last comparison is moderates versus conservatives, moderate conservative, 2, 3 here. We see a difference of 1.49, and then our p-value is less than 0.001, so we have a significant difference as well between moderates and conservatives, and this is what we thought. When we looked at those mean scores, we assumed that conservatives were scoring reporting more feminist prejudice compared to liberals and moderates, and it seemed like liberals and moderates, it didn't seem like there was a difference, and that's exactly what the post hoc tests are telling us, the p-values here are telling us. But significance does not equal importance, so we are going to report the d value for every comparison that we have. And so, as we talked about in class, we have to calculate our d values. We're going to calculate a d value for each of our comparisons, Cohen's d. Unfortunately, ANOVA does not calculate our d value, sadly. So we have to calculate ourselves. And so we need to take each mean difference and divide by S pooled. S pooled, meaning we need to take the average of the standard deviations. Because now we have 3 standard deviations. We have a standard deviation for liberals, standard deviation for moderates, standard deviation for conservatives. And so we need to calculate a average, a weighted average, since our little n's here, the number of people in each of these independent groups, are different. So we need to weight the standard deviation by how many people there are in each group. Right? So more people in the group, that standard deviation will be weighted a little bit more. I say a little bit because there aren't huge differences in the n's for our independent groups, right? And so in order to get S pooled, we have to go back to the ANOVA table, between subjects effects table, the omnibus table, and we need to take a look at our mean square error. So we need to take the square root of our mean square error, and that will give us our S pooled value. So relatively nice and simple actually here. So 3.48 if we're rounded to 2 decimal places, and then we'll take the square root of that and we get 1.87. So 1.87, that is our S pooled. So we're going to take every mean difference and then divide by 1.87, our S pooled. This is the average, the weighted average of all the standard deviations for our independent groups. So if we go back to our multiple comparisons table, where to go? There we go. All right, so we're going to take each mean difference here, divide by 1.87. So for example, liberal to moderate, the difference is 0.04. Not worrying about positive or negative signs right now, because whether D will be positive or negative will depend on which group is listed first in the output. So if liberals are listed first in the output, if we're comparing liberals to moderates, then our D value is going to be negative. But if we compare, if moderates come first in the sentence, then liberals, then the difference is positive, so the D will be positive. So it doesn't really matter positive, negative right now. Just going to take 0.04, divide by 1.87, oops. Right. And that gives us a D value approximately to 0.02. Right. And then we have liberal to conservative, 1.52, divided by 1.87. We get 0.81. And then we have moderate to conservative, 1.49. We get 0.80 for rounding to 2 decimal places. The 6 moves up the 0.79 to 0.80. So for moderate conservative, we have 0.80. And so these are our D values, right? We see that, again, non-significant difference between liberals and moderates. So liberals and moderates did not differ in terms of their self-reported feminist prejudice, but then we see that we have large differences between liberals and conservatives and moderates and conservatives, with conservatives hence reporting a lot more, much more prejudice towards feminists when compared to liberals and moderates. So yeah, that's it for Between Subjects, one way between subjects ANOVA, looking at the effect of political orientation on feminist prejudice, taking you through about how to conduct the test and how to read the output, interpret the output. And a separate video will go over about how to make a line graph. So we took a look at line graphs in terms of trying to predict the results, and then you actually saw the line graph of the actual mean scores, right? This thing, this line graph. And so there'll be a separate video about how to actually produce line graphs. I won't do that here. We're already pushing 20 minutes now. But that's it. I will end it here, and hopefully you enjoyed.